Hello everyone! So you will see on the blog that you have some PowerPoint slides that will go along with the video. I think what I'd like to do today for our video is just go through all of the slides that don't really have a lot of math in them, and so we can just kind of get like a basic understanding of what stoichiometry is and what mole ratio means. And then tomorrow we'll do like several example calculations together, and then I'll have you work on some of them on your own. So for right now, make sure that you have open your notes on stoichiometry. I think that as long as you go through, it'll help you so you know kind of like where we're going with this. I put this on your title page for stoichiometry because a lot of times I think that chemists would think of stoichiometry as trying to reason through a problem backwards. So sometimes we have to start at the product and work our way back to the reactant, and that's something with stoichiometry. So I just thought this was a good quote. Just to review, stoichiometry is going to include chemical equations and chemical reactions, which we just got done with. So again, just as a review, a chemical change will involve some type of reorganization of the atoms in one or more substances. So all that means is, remember in a chemical reaction, we break bonds and then we form new bonds. So in some type of chemical reaction, we have chemical changes where we're just rearranging the atoms. So we're not going to have exactly what we started with on the product side. So let's just say, for example, that I have C2H5OH, and I react that with O2. Those are my reactants. But the way that these are rearranged is going to change when I come over here on the product side. So I have CO2 and H2O. And we would see that this is a combustion type of reaction. We see that that's nice and balanced as well. When the equation is balanced, it has some type of quantitative significance. Remember, we use the word quantitative to represent what? Quantities or numbers. So a quantitative significance is just telling me that I have 1 mole of ethanol, C2H5OH, this is ethanol. 1 mole of ethanol reacts with 3 moles of oxygen. Well, I have a 3O2 here. So these coefficients out in front are now something that we are going to use as mole ratios. A mole ratio is just the ratio of moles in a chemical reaction based on the coefficients that we place to balance. So I have 1 mole of ethanol, because I only have 1 ethanol here, reacts with 3 moles of oxygen, because I have 3 O2s right here, to produce 2 moles of carbon dioxide. I have 2 moles of CO2, because I have 2 carbon dioxide molecules here. And then 3 moles of water, because I have 3 molecules of water. So I know my mole ratio because I have a balanced chemical reaction, which you've done and you're pros at now. So when they say 1 mole of ethanol, it's coming from the coefficient out in front. Reacts again, 3 moles of O2. So I'm just seeing that the mole ratio, again, is just coming from these coefficients out in front. Okay, so what exactly is stoichiometry? Stoichiometry is the study of quantitative relationships between the amounts of reactants and then the amounts of products in a chemical reaction. So doing a chemical reactions, that was really looking at qualitative relationships. We were really looking at properties and descriptions. But stoichiometry is taking that a step further, and now we're going to get into some math with chemical equations or chemical reactions. So stoichiometry is just the study of quantitative. So I'm looking at numbers, I'm looking up quantities, specifically between how much reactants do I have and then how many products do I have. Typically, a chemical reaction will stop once a reactant is completely used up. So like, for example, in your elephant toothpaste lab where we had hydrogen peroxide decomposing, once all of that hydrogen peroxide has reacted, the reaction's going to stop, because I only have hydrogen peroxide as a reactant. So if I run out of it, I can't have the reaction anymore. So chemical reactions are going to stop when one of the reactants is used up. Stoichiometry is also based on the law of conservation of mass. And what is that law? What does that law mean? Law of conservation of mass means that the mass of the reactants will be equal to the mass of the products. So again, law of conservation of mass means that the mass of the reactants will be equal to the mass of the products. So it's kind of like that law of conservation of matter. I can't create or destroy matter. So if I have the same elements and they're balanced on both sides, I should have the same mass on the reactant side as my product side, because I should have the same amount of each element, and I should have, or the same amount of each atom, and then I should have the same atoms on both sides. So law of conservation of mass, mass of the reactants is equal to mass of the products. Nothing should be changing here. Okay, so just to look at a few relationships, just so that way you understand kind of what I'm saying, I gave you an example of a reaction here. We have iron plus oxygen makes iron 3 oxide. And this is a balanced chemical equation, because I see I have 4 irons, 6 oxygens, 6 oxygens. So we're good. So if I wanted to say this in words, if I wanted to say this reaction out in words, I would say iron plus oxygen makes iron 3 oxide. So if I ask you to say it in words, it's as simple as that. If I were to ask you to say it in terms of particles, I would say I have 4 iron atoms, because it's just a single element there, so that means they must be atoms. So 4 iron atoms plus 3, how would I say O2? Since there are 2 oxygen atoms and they're bonded, makes it a molecule. So 3 molecules of O2. So I have 4 iron atoms reacting with 3 molecules of O2 will produce 2 formula units of iron 3 oxide. So remember in that mole chapter, we went through and we said that there are several types of particles. One type of particle is an atom. And atoms are just what I see on the periodic table. Those are just my elements. Molecules would be some type of molecular compound. So I have to have some type of covalent bond. But that means that there has to be more than one there present. So I'd have to have 2 or more present there. So O2 can't just be an element because I have a bond there between those 2 oxygens. And since oxygens are both nonmetal, means it's going to be a molecule. It's a molecular compound, so it's a molecule. Fe2O3, that is an ionic compound. And another name for an ionic compound that we learned in that mole chapter was a formula unit. So I have atoms, molecules, formula units. Again, it's an element, means atom. O2, that's a molecule. Fe2O3, ionic compound, so that must be a formula unit. So if it asks in particles again, 4 iron atoms react with 3 oxygen molecules to produce 2 formula units of iron 3 oxide. Okay, so there's my particles. Now I want to talk about it in terms of moles. What about moles? So remember, I know how many moles there are of each atom or molecule or formula unit because the coefficients in front tell me how many moles of each I have. So I have 4 moles of iron reacts with 3 moles of oxygen to produce 2 moles of iron 3 oxide. Okay, lastly, or almost lastly, mass. So if I wanted to find the mass of each one, how would I find the mass of 4 iron atoms here? How would I find that mass? Well, we all need to get out our periodic tables. We're going to look at those periodic tables. We're going to find iron on that periodic table, and we're going to see that the mass of that is what, my children? 55 point something? Maybe around like 56 if we rounded. So I don't just have one iron atom though. How many do I have? I have 4. So I'm going to end up taking that 55 times 4 to get a certain number there, and that will tell me how many grams of iron I have. That's my mass. If I want to go on to oxygen, I have O2. Well, I know oxygen has a mass of 16, but I have 2 of those, so it's really like 32. So if I want to know the mass of how much total oxygen I have here, what would that be? If this is 32, but I have 3 of them, I'm going to take 32 times 3, and that's going to give me what? 96. So I should have 96 grams of oxygen. If you did your iron, you should have 223 grams of iron. Now, let's look over here. Fe2O3. Since that's a formula unit, I'm going to have to try to figure out the molar mass of this one, right? Or I'm going to try to figure out the mass of this compound. So I know that my iron has a mass of 55.847. So we can just say 56. So I have 56 but times 2 plus oxygen, which is 16, so times 3. So what would that give me? You should get 160. So you should get 160 there, right? Hopefully that's what everybody got. So Fe2O3 would have a mass of 160 grams, but how many Fe2O3 formula units do I have there? Well, I have 2. So if this whole thing is 160 all by itself, but I have 2, I'm going to double that. So that means that I would have 320 grams. So let's go back. If I wanted to know the mass of all of these. So we said iron has a mass of 56, but I have 4 of them. If I did 4 times 56, that would give me 224. So I have 224 grams of iron. Reacting with, we found that oxygen was 96 grams. So again, 224 grams of iron reacting with 96 grams of oxygen, producing 320 grams of iron 3 oxide. So that tells me how much mass each one of these have. And all I did was I found the mass using my periodic table, and then I needed to multiply that by whatever coefficient was in front because it tells me how many of each one I have. Okay, lastly, total reactants and total products. I want to know what's the mass of all of the reactants together, and then what's the mass of your products together. So we found that iron, 4 iron atoms, has a mass of 224 grams. And we said that oxygen has a mass of 96 grams. So if I took 224 and added that to 96, we should get 320 grams. So on the reactant side, I have 320 grams. Well, I know that I had over here 320 grams. So I have 320 here, I have 320 grams here. So then that means that I'm good, I'm balanced, and I am abiding by that law of conservation of mass, which means that the mass of the reactants must always equal the mass of the products. So that means that I didn't create or destroy anything. I'm still conserving all elements, all atoms on both sides of that reaction, okay? So let's move on to this next slide. A mole ratio, again, is a ratio between the numbers of moles of any 2 substances in a balanced equation. So let's look at the equation that I give you here. You have 2 aluminum atoms plus 3 bromine molecules will produce aluminum bromide, or 2 formula units of aluminum bromide. So let's just say I want to know what is the mole ratio of bromine to aluminum. So here's bromine, here's aluminum, and to find the mole ratio, I'm just going to compare their coefficients. So bromine has a 3 in front of it, aluminum has a 2 in front of it, So the mole ratio must be